In this video, I want to talk a little bit about how we position the detector and prepare to insert the EBSD detector. So this, in this particular sample here, this is a metallographic mount, and my stage on this microscope is tilted to 70 degrees. And I can see that if I come up here to collect image and I click on this area here for the details, you'll see it's reading the stage tilt as essentially 70. It's on the microscope, it's set to 70. It's actually putting out 69.9. There might be more decimal points going on behind the scenes. But this is important because it tells us a few things. First of all, my sample's tilted 70 degrees. If I come in, I'm just for comparison's sake, I'm gonna, on the microscope, change this to 50 degrees. And if I look here, you'll see it now reads this as 50. If I had a pre-tilted holder, I could, in 20 degrees, 50 degrees, add that to 70. 70 is the typical angle we target for. We can actually operate anywhere between essentially 60 and 89. So you can project the beam onto the sample, but we target 70. That's the most typical condition. So I'm going to go back to my 70 degree pre-tilt or stage tilt and put in a 0 degree pre-tilt to kind of go back to our number here. And you can see when I put that number in, it's going to recollect the SEM image because we have changed the tilt. You'll see that the image we're looking at, it might be a little out of focus from having adjusted things. So I'm going to tweak that very quickly in live time. Okay, so that's now in focus. I will recollect the image. We'll see it's going to sharpen up a little bit in terms of what we see here. But what you'll see is that this image does not look tilted, and that's because we have the tilt correction turned on here. If I turn this off and recollect it, you will see, you can now maybe see that there's more of a tilt on the sample. And so you can see that the grains are now have a distorted aspect ratio. We're looking at a tilted sample. The tilt axis is left to right. The tilt direction is top to bottom. And that's what we set here. We're going to turn on the tilt direction is vertical. That's what I have set here. And I'll turn on my tilt correction. You get a tilt corrected image. I like that on just because it shows an image of what I expect of the area of interest. You can certainly run it either way. It doesn't make any difference. So we're now underneath the beam. We're positioned. I'm at a working distance of about 15 millimeters. Each system will have essentially an EBSD working distance and a working distance range. So if I look under my calibration here, you'll see my system has been calibrated anywhere from 10 to 20 millimeters working distance, and I'm right in the middle of that, 15, which is pretty typical. Your EBSD signal intensity will vary material to material, but you can work within that range. But generally, you try to work, if my working distance is 15 nominally, I'm usually working somewhere between 12 and 17 for most materials. But I'm now positioned in that. I'm tilted to 70 degrees. I'm in the right working distance range, and I can insert my detector. I'm going to let that go for a second. So the detector is now inserted. You can actually see the external control is on here. If I turn that on and off, you'll see that the pattern basically goes away, and we'll address optimizing the pattern in a subsequent video. But we're able to safely insert the detector because we have the sample tilted to 70 degrees. If the pre-tilt or stage tilt were at 0, you would get a tilt error when you would appear, and it would also appear if you try to insert it without it having that setting. The other thing I want to show in terms of setting up the geometry, if you use this little acquisition options button here, is you'll see we can turn on the EBS detector cooling. I could move it in. We can see our column and stage control values, but for EBSD, this is also where we can enable the transmission or TKD mode. for operation. That's will be a different topic. But just to be aware that that's some of the options that come out of this acquisition mode.